Okay, I think we're rolling. So, hello Dash community. This is Ryan here. I am making a video to go along with the proposals for the so-called high performance masternodes, and I will bring that up in just a minute here. So, this particularly, I'm making it for this 1K dash collateral version, but the point with this video, we're already kind of far into the voting cycle. Actually, not very far, but we've got a lot of participation, a lot more than I thought that we'd have in the first few days here. So we're kind of well along already, and so the nature of this video has changed a little bit, but it's still, I think, will be useful for anybody that's interested in the whole concept of any of these options that are being proposed. But in particular, this is about this video, this option right here for 1K high performance master nodes. So the other ones are obviously the every node runs platform, 4K high performance, and 10K high performance. This is my proposal. I'll just actually scroll through it just in case, just so you can see it and pause. You can read it in the video if you want to just read it in the video here. And then there's some comments. So that's the proposal, but I do want to kind of go into some detail about how I came about this, why I'm doing it, and how I've modeled it. So I'm going to go back here to the model that I created. And my goal here, well, let me step back again. The goal with the whole proposal, there were two goals. Goal number one is to give the community an option that I think was requested, not just by myself, although I'm one of the biggest proponents of it, but there were several other people that I think wanted this as an option. And so I wanted that to be something that people could vote on. And then also I wanted to educate people about how these numbers are calculated, not just for the 1K time lock, as I'm calling it, but for all of the proposed options, so that you masternode owners can make an informed decision about it. And I guess let me just bring up my face again while I'm not getting into too many details here. So yeah, that the point is to just give you an option and help you have an informed decision, and not just these are the numbers and not really understanding what the numbers are. I want you to fully understand what the numbers are, fully understand the assumptions, and the calculations that go along with them, so that you can trust this process. So I'm going to describe one of the scenarios first, and I think I'm going to start with the 10K voluntary solution, 10K high performance masternodes, if you like that term better. I'm calling it voluntary because it's an opt-in system. We're not required, masternode owners are not required to upgrade. That would be opposed to or contrasted with the 1K mandatory and the 4K voluntary. And then again, this is essentially my proposal, this 1K time lock, and then there's this 1K voluntary is kind of a variant. These two are just variants of each other that I'll explain later as we go. But like I said, I think it's probably easiest to start with the 10K voluntary, just because 10 is easier on the math, and it illustrates many of the concepts. So I guess there's probably no way for me to keep, is there a way for me to keep this video and me up here? Probably doesn't really matter. So the collateral is 10K. 50% of the rewards will be split there's a little bit of nuance behind that number that I guess Quantum Explorer Sam can describe more if he'd like. But the bottom line is that at the end of the day, 50% of the rewards will be going to people that run platform and core, and then 50% will be going to people that just run core. So that's what that number means. That's the allocation to the platform nodes. And then we have the exchange rate, which I've set to 45. And as you can see, the price is about 45. I think this is the same number that DCG used in their models, so that should be fine. Platform hosting costs. This is the cost that it will cost, the estimated cost for hosting a platform masternode that runs core and platform services. The way I got this number 75 is I basically asked Sam, CTO of DCG, what will be the cost that you think that will be required in order for these nodes to get paid, because I think that will be the main idea, is that people will run nodes just powerful enough to get paid, and some, there will be some that run higher performance just because they want to help the network, but I think most will probably just get by with what they can. And his answer to me was, I think it will probably be $50 initially, and maybe $100 6 months down the road. So I just split the difference and called it 75. This whole model is mostly based around launching. So we're assuming that there's no platform demand and that there's therefore no revenue for platform nodes for the data storage and all that stuff. So that's kind of the assumption throughout this whole modeling, is that we're just modeling the initial conditions and maybe the first 6 months. So if we take that as granted, $50 to start, $100 in 6 months, maybe it averages out to 75. That's the idea there. The masternode hosting costs. So what I'm calling platform nodes are the nodes that run core and platform services. And then what I'm calling masternodes here is the ones that are just running core. So that's what we have currently today. So if you look at this current cell, we're just estimating at $25. So this current column describes the calculations for today's system. We don't have platform nodes yet, so that field is empty. We have master nodes only, and they have a 1,000 dash collateral. And although the number floats a little bit on the node count right now, I think it's a little bit higher than this, maybe 3,840 or something like that, but I'm just going to keep it to 3,800 so I don't have to keep chasing that number. And then the masternode gross yield is 7.43, and the net yield is 6.76 with those numbers. Now, the difference between the two is the hosting cost. So if you put the hosting cost down to 0, these numbers would be the same. So the difference between gross and net is the hosting cost. In reality, actually, that's the only way that it will work in this system right now. But as we move over this column, the 1K mandatory, I guess I will just go ahead and talk about that since we're right here. The whole plan all along for the past 6-7 years or whatever was that we're going to eventually release platform, and then we will require all the nodes to upgrade to that, to running platform. And then just recently, we found out that there are some concerns about that, and there are concerns about every node hosting the hosting platform. And we've listed those concerns in the proposal. Both me and DCG have listed those, so if you want to look at those concerns. But basically, it was like the costs are going to be high, and there's some security issues, and we don't necessarily want everybody being forced to run platform if they don't want to. So there were a lot of reasons why this 1K mandatory system was not a great plan. So then people started thinking about what the alternative plans could be that kind of address these concerns. And there was a lot of discussion. I felt like there were a lot of people that wanted to keep the collateral the same, but make it just optional to host platform. And there were and are some security concerns with that. And that's actually why Dash Core Group did not end up proposing a 1K voluntary system because of security concerns. And I'll talk about those in a minute. But I just wanted to round out this 1K mandatory system. So if you look at the costs, there are some assumptions built into this that I probably won't go into all the detail about how to get to these. And these specifically these cost numbers take with a grain of salt, because I'm not designing platform. I'm just trying to interpret what I think DCG is building. And so I'm modeling that. But we have 3,800 nodes still. As you can see, the current 3,800 nodes upgrade to running platform. And so there are no master nodes, and there are 3,800 platform nodes that are also running core. Now this number right here, the platform quorum size, is the way that platform works is there's a 100 node quorum or there are actually several 100 node quorums that get formed, but at any given time, it's my understanding that one of these quorums is servicing platform, which means 100 nodes, 100 randomly selected nodes are servicing platform at any given time. And there are various other quorums that are being formed, and then you switch over at a certain time period. This hypothetically risky platform nodes number is an important number to understand, because it's kind of the premise behind this whole security concern. And so with that, I'm going to actually flip over to this selected options model tab. What you're seeing here is basically just a summary of inputs and outputs, but the actual model is in this other tab. So if I go over here, let me actually switch this to the 10K, 1K mandatory, so that these numbers get pushed through into this model, and then this is where the actual calculations take place. So right now, this is the amount of Dash that's being distributed to, everybody. And of that, everybody, 51% of that is going to masternode owners. And that's to do with the block reward allocation schedule that some of you will probably be familiar with. And so these, again, some of those numbers from the other tab, they're brought over here. And so you have the 3,800 nodes. And if you just do the calculations, if you have this much Dash being distributed to this many nodes, you get 74.3 Dash per year that those are they're getting. So if you annualize that, you divide that by 1,000 Dash, your yield is 7.4. It would be 7.43 if we increase the precision on this number. So that's 100% allocated to platform nodes. And here's some security calculations that we'll talk about later. Actually, we'll talk about that later. I wanted people to understand the yield calculations. So if we kind of discussed this already. The gross yield over here. It's not labeled gross yield, but here it is. This is the gross yield. 7.4%. It's pretty straightforward on this option because there's no changes really. And then the exchange rate comes in, and there's nothing particularly interesting about this version, this scenario, because it's very straightforward. But what you'll notice is that the assumption here is that there's zero platform demand, and so the only difference between gross and net is you're subtracting the hosting costs. And so the hosting costs in this case are basically these are some assumptions, and again, these assumptions could be refined, but basically if you go out on the internet and you do some research about how much storage costs, I'm not going to go into all these numbers, but some of this is from DCG. As much of this is from DCG as I could get. They're assuming that we're going to be charging people for 8.8 years of data right up front. So when somebody wants to store some data on platform, instead of charging them over time, you give them a one-time charge that it would cost to store this data for 8.8 years. And the way they got that number is they'd have to tell you exactly, but in the conceptually what it is you can kind of estimate the cost that it would take for, like, say 50 years to store this data in terms of today's cost. And because the costs of storage go down over time, it's less than 50 years of effective storage that you could charge them and basically have them have storage for a long time. And I think it's basically forever as far as I'm concerned, as far as I know. And so if you assume that it costs $3.75 per gigabyte per year per node, then you multiply that by 8.8 years, and then you multiply that by 3,800 nodes, you would get that we need to charge people $125,000 per gigabyte of storage. And so if you convert that into Dash, that's 2,787. If you convert that into Duffs, it's that. And so the net yield is 5.4%. Actually, yeah, that I was just explaining the way that the costs are calculated, the storage costs, and it's different for each of these scenarios. So now that's probably a good time to switch back over here and look at that. And again, now I'm going to actually skip over to the 10K voluntary system. So the idea here is that when in this scenario, you're requiring 10,000 Dash for to run one of these nodes. You're going to allocate 50% of the rewards. These costs stay the same. The quorum size stays the same, and this risky nodes has dropped from 270 down to 27. Let's look at where those numbers come from. Where does the 270 come from? The 270 comes from this data that ultimately comes from MNO Watch. So shout out to MNO Watch for creating these classifications. Through their analysis, they've estimated that there's a cluster of nodes that can safely be assumed to be owned by the same operator. And in this case, the highest one that we've observed is 270 nodes, all operated by Binance. And then the next one, these are just made up names that they've given to these different groups of people. And so the next highest is 229, the next highest is 128 nodes. Now the theory behind the 10K system is that when you increase the collateral required to run a platform node, I guess I'll go away from now since I'm right here in this corner. When you increase that, it's possible that Binance could convert and upgrade all of their nodes to platform nodes. And because it's a 10x change from one 1,000 dash collateral to 10,000 dash collateral, they could spin up 27 platform nodes and no more. They could spin up less, but the worst case scenario in this security calculations is that they spin up all of them, and so that's 27. So if we go back to this these calculations again here, this is 27 risky nodes. Now, why are they called risky nodes? They're called risky nodes because the risk is that they spin these up and then they start running platform. We release platform, we have it start, and then anybody is free to basically start operating these nodes. And so if you have 270,000 dash, you can spin up to 27 platform nodes. But what's the risk is let's say that they all go offline at the same time, and there's a 100 node quorum that potentially could have many of these Binance nodes in there. Now, in this case, the maximum number of nodes that you could have in this 100 node quorum is 27. So the maximum percentage that you could possibly have is 27% of a 100 node quorum. Now that is by definition of the proof of stake consensus algorithm not risky at all. The risk is when you have 33%, you start having risks of things. And there are a couple of breakpoints that are important that I won't go into the details about. I think most of you probably already have heard these. But 33%, 1/3 of a quorum, you have a risk of halting the platform. And at 66 or 2/3, 67%, you have risk of platform of actually stealing funds. So those are kind of the two important numbers: 33%, 66%, 67%. So 27 obviously is less than 33. So the risk on this is literally zero. So down here is the risks. And it's probably a good time to go into that calculation now. I'm going to go flip over to this other tab here. But actually, let me just explain this real quick, just conceptually. This is the chance of one risky quorum forming, and that's 0% because 27 will never be higher than 33. You'll never have up to and over 33 of these what you call risky nodes in a quorum. So the risk, no matter what the time frame is that you're considering this risk, is 0. And these other numbers will be a little bit more important later. But conceptually, again, let's just imagine that we were talking about something like one of these scenarios where you could have more than 27. Our biggest whale could have more than 1/3 of the quorum, and there are scenarios where that's true. In that case, even if a quorum forms with more than 33% of that quorum, statistically speaking, being formed, the risk of that, or the probability of these quorums forming, is very low when you consider just one quorum formation. But when you consider that the quorums are forming continuously over a certain duration, then you eventually get into a scenario where even if the chance of it forming for one quorum formation is very low, over time that compounds. And so this, you kind of have to have a risk time frame, and I'm just calling it 6 months right now because I think that the platform should be, once we release it, it shouldn't take longer than 6 months for us to reach equilibrium. And by equilibrium, I mean that the yields start approaching each other. So I should probably talk about that. I'll talk about that in a minute here. Just this last number, the overall chance of failure is this times this. So just look at these numbers for a second on this 1K time lock. if you find out that the risk of your quorum failing is, or the risk of a quorum forming is 5.18% over this over a 6 month period, but you personally, this is a totally subjective number. I totally just made this up, and it's up to everybody else to decide what this number should be. I'm calling it 10%. A, because it's a nice round number, and B, because I think it's actually conservative. If and when that quorum fails, or not fails, but when it forms, when you do have more than a third of those risky nodes in a quorum, which again happens about statistically 5.18% of the time over 6 months. There's a 5.18% chance that one of those will form over 6 months. But if it forms, what's the chance that it will actually be faulty at that time? That's what this number is. So if you think that Binance is actually just really waiting for them to have nodes in their quorum, and they want to take the platform down for whatever reason, this number would be 100%, because if you are assuming malicious intent, then they could just program it so that they could know exactly when their nodes are in the quorum, and then they could shut it down. So you'd want that number to be 100%. And if that was the case, then the overall chance of failure would be 5.18% times 10 times 100%, or 5.18%. Now, if you think that that's a 1 in 10 chance that will fail, meaning maybe they're not maliciously waiting around for this opportunity, but it might just so happen that they're upgrading their nodes, or that something happened and all of their nodes went down at the same time, while they were in this statistically very unlikely scenario where they're consisting of more than 33% of the randomly selected quorum, then your overall chance would be 5.18% times 10% chance that they'll actually take that opportunity, or that there will be a failure during that time. And then your overall chance would be 5.18% times 10%, which would be 0.52% chance of overall chance of failure. That's less than 1%. So I haven't really got into the time lock scenario. I haven't really described that yet, but I just wanted to describe what these security calculations are. So I'm actually going to describe them in more detail here. And I apologize, this is going to be a long video, but you don't have to watch it. You can skip through it, whatever. You can watch parts of it. Maybe I'll timestamp them. But here's the actual security calculations. Just for, actually, let me break away here and just kind of give some context here, just so you know why I'm talking about this. And if we look at the current standings in the voting, it's pretty obvious right now that there is a winner or at least one option is very much in the lead, and that is this Evo Decision 4K, the 4K option. That is actually in positive territory. The absolute yes votes are 292, so 426 yes, 134 no, and so that's a net 292. All of the other options, including mine, is very low. And so I actually don't really have much hope that this 1K decision, this 1K voluntary system is going to pass. But I do still want to document what I think the risks are of these different scenarios, and at least document this for historical sake. And along the way, if you do decide like, oh, I didn't really understand what the whole thing was about, maybe this video will help. And even if we're just deciding between some of these two, this video will help so that you know what the security calculation risks are. And I haven't got into the yields yet, but I'm going to compare those as well. So hopefully this will be educational and helpful for everybody, no matter what option you prefer. By the way, this is mnowatch.org/leaderboard. This is by far the best leaderboard that we have in Dash. It's probably the only one, I think, right now. But it's very useful because, as you can see, what you can do here is if you refresh this page, this might turn green. Actually, it didn't, because when you do have new data, new votes come in, this will be green, meaning that it's a link that you've actually visited. But this is, you can come in here and see what the votes are doing over time. So as you can see, some votes are coming in over time. If you don't know this site yet, you should probably take a look at it. It's pretty awesome, actually. The most recent votes, one for Dash Incubator, yay, and this proposal. So I've got these the ones of interest here in this video are in red right here. So I go back here. I just wanted to give some context behind my explanations here. I don't have any. I'm not very optimistic that what I consider the best option is going to win. But that said, I'm actually very happy with how the voting is turning out, because my main concern wasn't necessarily that I thought that there was a problem with these other solutions. It's that I thought it was going to be very contentious, more contentious than it appears to be now, and that it would divide the community. But I'm happy to see that there is somewhat of a consensus forming around this 4K system. So that's great. But let me go back to these calculations, the security calculations. So again, if you have a 100 random node quorum and 33% is a breakpoint about what there could be problems beyond that, then that would be 34 nodes. And hypothetically, this was just, you could hypothetically increase that number by some percentage, but that's not being used in this. I was going to go into some more detail about these calculations, but I don't think that I am. It's getting a little long-winded as it is already, so I'm just going to just know that that's where the calculations are actually taking place. And if you want to look into these formulas, feel free. This is a public spreadsheet. You can take it, copy it, inspect it, see how the calculations are working. The kind of the hairiest calculation here is this one right here. You can see it's using this function, hypergeometric distribution. It's a function that has 4 different inputs, 1, 2, 3, 4. It's taking into account the population size, let's see, there should be another one. It's taking into account the population size and a sample size, and what you consider a successful random grab between the sample and the population. So that's basically what it's calculating. I could explain it more, but one way to think of it is like if you have a deck of cards of 52 cards, and if you wanted to play a little game and say, I'm going to select 10 random cards from this deck of 52 cards, and if I get, say, of those 10 randomly selected cards, if 5 of them are a face card, then I lose, or something like that. So that's the kind of the probability calculation is you have a population and then you have a sample. In my example, 10 would be the sample and the population would be 52, and then you have some kind of criteria that you're looking for, like 5 of 10 or 6 of 10, or in our case 270 nodes of uh, 270 nodes of 3,800 total would be the population, and then the sample would be are there 33 or 34 or 35 or anything higher than that in my random sample of the 100 quorum. That's the calculation. So I don't know if that made much sense, but that's what it's calculating. And again here, on a per formation basis, it's very low. In this case, it doesn't really have, there's no scenario where that would be more than 0. So I'm going to go over here and actually exchange this now. I think it's probably a good time to talk about the 1K time lock situation or option. What we have here is you're keeping the collateral at 1,000 dash, and then you're allocating 20% of those, 20% of the total masternode allocation, you're allocating that to platform. And we've talked about these numbers. In this scenario, I'm increasing this random node selection to 150. I have to do that because of the security concern. And I'll show you what happens if we decrease that back down to 100, so that you know what the concern is. Also, I'm saying here that this only tolerates 135 risky nodes instead of 270. That's essentially what I'm assuming. And the reason that I'm assuming that is because of the time locks. So this is, for anybody who hasn't really heard the explanations of why time locks make sense for this scenario. If you introduce time locks, say 6-month time lock or 3-month time lock or even 18 days or whatever, that's going to discourage some people from taking part in platform. Just like 10,000 dash would discourage some people. If you only have 5,000 dash, then you can't join a 10,000 dash platform system if we're not considering shared nodes and everything. So it's the same idea between these two scenarios. It's just the difference is one is discouraging people by not being able to or not wanting to purchase more dash, and then the other one is discouraging people from or preventing people from joining platform if they're not committed enough to time lock their dash. So, but in either case, you're limiting the participation in platform. One in the high collateral scenario, it is feasible that somebody that even doesn't have 10,000 dash, they could borrow 10,000 dash, borrow $10,000 worth of dash, buy that dash, spin up nodes, and then they would be then, if you did that with 2.7 million dash or whatever, then that could be, or even more than that, 3 million dash, that could be a risk as well. But getting back to the 1K system, if you put time locks, then it's not reasonable that or at least I don't think it's reasonable to assume that Binance, for example, is going to turn on all of their nodes and lock customer funds into nodes. I mean, it's possible. Is it likely? That's for you to decide. And I think a lot of people have already decided that, but I don't know why people are voting for the 4K or voting against this, but the 1K solution. But that slight risk could be part of it. So I want to talk about these yields now, because that's kind of the premise behind how many nodes we'll expect to run platform. So in this case, you have, when you allocate 20%, then you're going to have a certain amount of dash that's going to a relatively small subset of the nodes. So 650 in this case. So, but if you wanted to work it out, like how did I arrive at this number, and how does DCG arrive at these numbers, 180 and 460? This is how it's done. So this is the time for you to tune in or timestamp this if you're curious about when I or Sam talk about an economic equilibrium. This is what we're talking about. If you have if you open up platform and say, okay, start joining platform, and let's say 10 nodes uh, jump on right away. What do the yields look like? These 10 nodes are going to start getting a huge return on their um, their investment of 1,000 dash. There, because you're sending 20%. Let's just make this an absurdly small number of nodes. One. The first node that jumps on, he's getting all of the allocation, this whole 20% of all the block rewards, of all the masternode block rewards, they're going to that one guy. And so what do you expect to see happen? You expect to see another guy say, hey, I want some of that. So another guy joins, and then that decreases the yield down here, and then 20 join, and then 200 join. And these yields are starting to come down, and right here you have the platform yield, gross yield, and the platform net yield. That these, you would think, the theory is that these are going to come down until they start coming into equilibrium between these two nodes, the platform net yield and the master node net yield, because somebody's looking at this and saying, hey, I have 1,000 dash, I want to join in too, and I'm willing to time lock my dash for that, or for example. So this number is going to keep going up until it's no longer any more beneficial to run a platform node than it is to run a master node in terms of the net yield, because again, there is a bit of a difference between the hosting costs. If these were the same, then these would be the same. And so you keep going up to 600, and at that point, now you're starting to see 7.41. That's pretty close to 6.39. Let's go to 650. 6.69% compared to 6.5. At this point, people are starting to say, hey, I don't know if I want to go through all the trouble to set up a platform node, because I'm getting just as much yield over with the simple $25 node that's very relatively more reliable, easy to run, things like that. And just to hammer this point home, if you increase this to 700, well, I guess 700 illustrates the point. At 700 nodes, the platform net yield is 6.07, and the master node is higher. So nobody's going to say, hey, I want to go through some more complications and spend more to get a lower yield. Nobody's going to do that. And so that's why it stops. Let me back that up to 650, and I'll actually back this all the way up to where it used to be so that the calculation is not overwritten. So we're back down to this. This is basically market equilibrium. That's where you expect it to land. Now you can do that same calculation with all of these options. I will actually do that for the 10K scenario just to illustrate the point. So 10K voluntary. Now these numbers are being fed into the model, fed in and out of the model, and you do the same thing. So you at first you barely announced platform is open for business. You can come spin up a platform node. The one guy does it. He's getting an enormous yield. and then 10, and then 100. And you can see these numbers starting to get closer to each other. And let's say if 200 really wanted, if there was a market demand for 200 of these, what would happen? You'd have that same problem. The master node net yield is higher than the platform net yield. And so that's before that happens, people start saying, hey, I don't want to make that upgrade. And so you get back down to this, this number right here is what I've called, we're calling it 180. Now you might look at this and you might say 7.64, there's still room for some more nodes there. Let's do 190. Okay, that works. It's still higher. Let's do 195. Okay, that's still working. That's about, so why didn't I stop at 195 here on this 10K? Well, two reasons. One, DCG modeled it at 180. They stopped at 180 for some reason instead of going all the way up to 195. And that could be for various reasons. They could have modeled it where the price was lower, like 40 or something like that, and then there's less of an issue. Or they could have modeled it, actually I think they do model it at 100. And so now you're starting to see why DCG modeled it. Actually, no, we're still up at 185. So if we have those numbers and we have 195 or 180, at 180, so there are various reasons why they could have stopped at 180. I won't guess what those are necessarily right here, but I did want to point out one thing about this number 180. Let me go back to the formula. Okay. What is this assuming? Okay, you do know that there is still a market incentive to keep increasing the platform nodes up to and even beyond 180. But what is the problem? What's the other problem that you might be coming up to? And that's where I'm going to flip over to this model again. As you can see here, this is the list of nodes that currently own and operate master nodes. 200, again, Binance 270, Wejohnny 229, When it's a 10K system, these all get dropped by a factor of 10. And if you add all these up, these are the known clusters, again, by MNO Watch. If you add all those up, you get 160 nodes. So what is that assuming? It's saying that of every single cluster that that MNO Watch has identified, 100% of those have to upgrade. And even if 100% of those upgraded, we'd still only have 160 nodes, 160 platform nodes, not 180, 160. So why did we go all the way up to 180? Shouldn't this be 160? Because surely we can't just keep making, we can't expect that people are just going to buy more Dash and run these. So why didn't we do 160? Well, for one, if you do have 160, then people might actually start buying Dash and to run a platform node, because 8.62% net yield is pretty good. That's pretty attractive. Of course, that comes at the expense of the lowly master node owners that are now only getting 5.75 instead of what they're getting now, 6.76. But the more probable scenario is that, or more probable situation is that, well, this is only what MNO Watch has identified, and there might be a lot more clusters than is on this page. So even though every single one of these only adds up to 160, there might be other clusters that MNO Watch just hasn't identified. And I think that they've said something to the effect of, well, we think that there might be even up to twice this many that are already invested in Dash, already running nodes. We just haven't identified them as clusters. So those are the kind of the several reasons, and it's just a judgment call about like what number we think that we're going to land on. We know it's not going to be higher than 200. We know it's not going to be too low, because there's just if it was only 100, that's just a really attractive yield, and people are going to start piling into that. So you have to balance all these factors, and DCG put it at 180, and I'm happy to. I think that's probably pretty close. So now let's just look at the 4K voluntary system real quick. That, after all, is the most popular choice so far. So let's look at what this means. Again, all these numbers are the same, except for we have 4,000 dash collateral instead. We're still allocating 50%. Personally, I think that's way too high to be allocating to an untested product, both untested in the sense of it's not actually, we don't have an MVP tested on testnet, so technical testing, we don't have that yet. But more importantly, we actually don't have market testing. We don't know if there's product market fit for what we've been building for the past 7 years. That is, to me, a significant risk. Betting 50% of our allocation, throwing it to an untested product. That seems a little bit not irresponsible, but more than is, I think, prudent. I think 20% is more prudent. But that's just me. So I hope I'm wrong about this, and I hope everything turns out great. But let's look at this 4K voluntary system again. 50% allocation, none of this changed. 100 random nodes. So 67 risky nodes. Where that's coming from, if you want to look at that, where that's coming from again, is you basically, you take, let's see, lost my train of thought there for a second. 67. I just ran out of mental steam for some reason. Okay. 67 nodes. I'm going to have to come back to that because I just had a brain fart and I don't remember where that is coming from. But this 460 nodes, this is what you expect to be the market equilibrium number of nodes in this system. And then when you have 460 platform nodes, you end up with 1,960 normal master nodes that are only running core, for a total of 2,420 nodes. I haven't talked about this yet, but this is also a significant thing. So if you haven't thought about this, think about it now. Like, we have 3,800 nodes right now. At the end of this, when we reach market equilibrium, we're only going to have 2,400 total nodes, 2,420 total nodes. So that's a pretty significant drop. It's a 36% change in our master node count, or 36% drop. I don't know if I said that. And in the 10K solution, it's even worse. You drop down 43%. So that's pretty significant. It's one of the reasons why I thought this was a better solution personally. You can make an argument that this isn't a big deal, and reducing our total master node count by nearly a half isn't a big deal. Maybe we had too many nodes to begin with. But if you think that maybe we have not enough nodes, then this should be very concerning. Regardless, let's keep going on with our scenario here. I haven't really talked about the sustainable or the pricing yet either, but there's just so much to talk about here. I won't go into detail. Again, it's getting long already. But you can notice just the general trend. The 1K mandatory system, what I've calculated to be the cost of turning up, registering a user and then having 10 friends. That'd be $5 in the 1K mandatory system. The cost of a 2,500 word blog post would be something around $2. And that's the 1K mandatory. That's the one of the main concerns, is that it was going to be very expensive for users of platform to be doing anything, and so only the most like censorship resistant, necessary and needed applications would be interested in this. But when you go all the way to the extreme, you drop that from $1.88 down to 9 cents for that blog post, or $5 down to 25 cents for a user with 10 friends. And that's pretty significant. That's a 95% drop in fees that we have to charge our users. So that's significant. And you can see the 1K voluntary, time lock, 4K voluntary, 88% drop is what the 4K gives us. So that's really a great benefit of this. And then the yields, if you just take a look, an overview of these yields, you'll see some things. For example, the 1K time lock system, you end up in all of these, the masternode net yield is going to go down slightly, at least, from 6.76% down to 6.14 and so on. It's highest in the 4K voluntary system, so that's great. That's the normal masternode. If you upgrade to a platform node, you're going to get 7.17%. So you actually increase your yield from the master nodes. So that would be a good reason to upgrade in that. And in the 10K, it's even better. The master node net yield, or the platform net yield, you have a nice little premium for upgrading up to 7.64%. The masternode net yield goes down a little bit, but that's because we're capping this at 180. If you kept going, then these numbers would be closer to each other. They'd basically be the average of these two. And so if you did that, then the masternode net yield would actually go up here as well. But again, it's harder to get these 180 nodes in the 10K option. It's relatively easier to get the 460 because there are a lot more people that have 4,000 dash on hand to be able to spin up these platform nodes than there are 10,000. So anyway, I'm not sure what else needs to be said other than pointing out again, this is a pretty low percentage, like less than 1%, I thought was a good deal in order to keep the 1,000 dash collateral, to keep the risk down to less than 1% of a risk of a node or a quorum failing. That's a pretty, in other words, 99.5% chance of success in terms of quorum formation if you believe these other inputs. And one of those inputs was this, you'd have to increase the platform quorum size to 150. If you didn't, let me just show what that looks like. If you didn't, then it would be, as I hit enter, take a look at this number, it's going to increase. It increases over here because this is where the actual modeled numbers are. So this is when Sam is saying, this is too risky. This is what he's talking about. He's saying, oh, and by the way, all of these, I changed this from 12 to 20, from 24 to 12. So if I put that back to where DCG has it right now, yeah, it's even worse. So that's why I'm recommending in my proposal, I'm saying reduce those quorum creations from 1 per hour to once every 2 hours, 12 per day instead of 24 per day. Increase the platform quorum size from 100 to 150. That gets you the security. And just to put a finer point on Sam's concern here, the risky nodes, you notice, is still 135. This is basically what this tolerates. 135, a 135 node whale. If a 135 or more node whale joined, then you would have more risk here. So let's bump this up to 270. Oops. 270. This is the number that's like the big scary number that Sam has used to say we're not even going to propose this option because there's a 100% chance over 6 months that you will have a risky quorum. Now, first thing to note is that even if you did have this 100% risk, if you do believe that even though you might have a risk of a quorum forming, that's not going to really be a risk of failure because there's some non 100% chance that, and in fact, I think so this is saying there's a 90% chance that even though that quorum forms and Binance has got all these nodes in this quorum, there's a 90% chance that it's not going to be a problem. I think that's actually conservative. I would say it's probably even high. It should be higher, a 95% chance of success, or what I've said here is 90% chance of success or 10% chance of failure. So that's an overall 10% chance. So even in this worst case scenario, I would personally think that it would be conservative to say that 90% chance that we're still going to be fine. Now, I know that's probably not good enough for most people, so that's why I kept tinkering with things until I could find a solution that addressed these concerns. So that's I'll just back up the calculations a little bit here so you can see what I tinkered with in order to try to get that to work. And as far as I'm concerned, those are totally reasonable things to be considering. Can we increase the quorum size? Can we decrease the quorum formations per time period? I actually did get verbal confirmation that was not a problem. It would just require potentially a higher performance node. And so, I think that it's possible. Even if we have to increase this from 75 to 100 or even higher, that might be the price to pay to keep this 1,000 dash collateral, because my concern was that having two different classes of master nodes would set up a social problem. I guess that's not as a big of a problem as I thought it was. It seems to be that most people don't either care about it too much, or they want the higher yield, or whatever the reasons are. So I'm not concerned if you're not concerned. For the most part, it was the contention that I was concerned about. So if we can come together and not have that, then great. But let me back this up again so you can see what I changed. So 135 again. The reason that works to me in my mental model is Binance is not going to spin up those nodes. Even the other whales are not going to spin up those nodes. I don't think that you're going to have, and it's not something that you just have to hope and pray for. You could design a system, a platform launch process that helped ensure this. And I won't go into the details because it just doesn't seem like people are even interested in exploring this anymore, but it would definitely be possible. So you can ask me about it later if you want, but I just don't see the point in really going into too much more detail. I've already gone into more detail than I probably should, seeing the votes already. But I just don't think that there would be people one single individual that's going to spin up all those nodes. But let me back this up again. So 12 quorum formations. There we go. So now we're back down to that less than 1% risk. If you just bump that up to 150, bump that down to 12, and then consider that you just have to tolerate only up to 135,000 or 135 node whale. And again, you can do that. You can design a system to do that, but not necessary apparently. So yeah, that I think I'll stop there. It's been a while. So I'll just go ahead and stop there, and let me know if you have any questions. Happy to answer more questions. But it looks like, let's just see if I can get this to show this going green. See if we got some more. Nope, no new votes since we started. But yeah, it looks like the voice of the people has spoken, and we're most likely going to have this 4K system, for better or for worse. So this has been Ryan. Thanks for the attention, and hopefully it was educational, even for the other options. So we'll see you in the voting.